Hello guys, welcome to the one more lecture on module 2, that is on complex line integrals. So in the previous lecture we learned about Cauchys theorem, statement of the Cauchys theorem and how to prove the Cauchys theorem. Along with that we discussed about different consequences related to the Cauchys theorem. So in this lecture I am going to explain about Cauchys integral formula, how to derive it, and also general form of the Cauchys integral formula. So first we'll see the statement for Cauchys integral formula or Cauchys integral theorem. Statement is, if f of z is analytic inside and on a simple closed curve C, and if a is any point within C, then f of a is equal to 1 by 2 pi I integration over the region C f of z by z minus a dz. So from the given statement, and we have to prove the f of a is equal to 1 by 2 pi I integration over the region C f of z by z minus a dz we have to prove here. So we will see how to prove that. So from the given statement we can take like this. Since a is a point within the curve C, so we shall enclose it by a circle C1 with z is equal to a as a center and r as a radius, such that C1 lies entirely within C. So I am taking two curves here. The first curve is C and the next curve is C1. I am taking it as a circle with center at A and radius r. So I'm going to assume that the circle C1 lies entirely within C. So here we can observe that. So to prove this word, we can use the second consequence of the Cauchys theorem here. So now the function f of z by z minus a is analytic inside and on the boundary of the annular region between C and C1. So the function f of z by z minus a is an analytic inside and also between the region between C and C1 also. So on drawing the figure, so here we can observe that the circle C1 having the radius r and center at A, and it is lying entirely within the curve C, and this complete figure I took in the complex plane. So now we'll see how to establish the equation now. So already I told that here we can use the consequence of Cauchys theorem. So I am taking the second consequence of Cauchys theorem, that is integration over the region C f of z by z minus a dz is equal to integration C1 over the region C1 f of z by z minus a dz. So since here the curve C1 lies entirely within C, we can take the equation like this. Call this one as equation number 1. So now the equation of C1 can be written in the form modulus of z minus a is equal to r. Since C1 is a circle with center at A and radius r, we can take the equation like this. So on expanding the circle, we'll get the equation like z minus a is equal to r into e power I theta. So in the next step here, I'm shifting a to RHS. I got the equation like z is equal to a plus r e power I theta, where the angle for the given circle C1 lies between 0 to 2 pi. So since I got z, I want to estimate the value of dz also. So to find dz, I'm going to differentiate the equation both the sides. I'll get dz is equal to I r e power I theta d theta. Since here a is a constant, it will become 0. So now I am going to replace all these data in the equation number 1. So the equation 1 implies that integration over the region C f of z by z minus a dz is equal to integration the angle theta varies from 0 to 2 pi. I am replacing z is equal to a plus r e power I theta here. So I will get f of a plus r e power I theta divided by z minus a is nothing but r e power I theta. So I wrote here, and then dz is nothing but ir e power I theta d theta. So on cancelling the term r e power I theta, r e power I theta, I got the equation like this. So the integration over the region C, f of z by z minus a dz is equal to, I can take the constant I outside, integration theta from 0 to 2 pi f of a plus r e power I theta d theta. I got it. So since here we can see that since r is very small quantity, we can take it as 0. So if r is equal to 0, the equation f of a plus r e power I theta will become only f of a, like this. So I got the integration over the region C, f of z by z minus a dz is equal to I into integration theta from 0 to 2 pi f of a d theta. Since f of a is a constant, I can take f of a outside, and the constant integration will be theta with the limit 0 to 2 pi. On applying the limit, I got I into f of a 2 pi I. So keeping f of a here itself, I am shifting 2 pi I to LHS. So my Cauchys integral formula will be like this. F of a is equal to 1 by 2 pi integration over the region C, f of z by z minus a into dz. So this formula can be applicable only if this z minus a is of order 1. So we'll see if the z minus a is of order n, what formula we can use it. So that I am going to explain by using general Cauchys integral formula. The statement is like this. So if f of z is analytic inside and on a simple closed curve C, and if a is a point within C, then f power n of a is equal to n factorial 2 pi I integration over the region C, f of z by z minus a whole power n plus 1 dz. So this formula can be applicable when z minus a whole power n plus n terms is there, means we can use this formula. Now we'll see how to solve this equation. So to prove this one, I am taking the Cauchys integral formula in the form f of a is equal to 1 by 2 pi integration over the region C, f of z by z minus a dz. So to find the f power n of a, I am going to solve this by step. So I am going to apply Leibniz rule for differentiation under integral sign. It means that differentiating the equation, above equation, both sides with respect to a, we'll get the equation like this. So I got f dash of a is equal to 1 by 2 pi I integration over the region C, f of z into dou by dou a of 1 by z minus a dz. So this step is obtained by Leibniz rule of differentiation under integral sign. So now differentiating this equation with respect to a, we'll get the equation like this. So we can keep f of z here itself, differentiating a, right? So I'll get minus 1 here, and differentiating 1 by z minus a, I'll get z minus a whole power minus 2 into dz. So now the equation will become like this. F dash of a is equal to 1 factorial by 2 pi f of z into z minus a whole square into dz. So now I am going to apply the Leibniz rule for differentiation under integral sign once again. Same, differentiating the above equation with respect to a again. So we will get f double dash of a is equal to 1 by 2 pi I integration over the region C, f of z dou by dou a of z minus a whole power minus 2 into dz. So again differentiating that, we will get it the equation like this. F of z is equal to minus 2 z minus a whole cube minus 1 dz. So I can write the equation like f double dash of a is equal to 2 factorial by 2 pi I integration over the region C, f of z by z minus a whole cube dz. So likewise, if I differentiate the equation for n times by using same Leibniz rule for differentiation under integral sign, I'll get the equation like this. F power n of a is equal to n factorial by 2 pi I integration over the region C, f of z by z minus a whole power n plus 1 dz. So here f power n of a denotes the nth derivative of f of z at z is equal to a. So in the next lecture, I am going to discuss about few examples related to the Cauchys integral formula and general form of the Cauchys integral formula. Thank you.